We live our lives on this invisible stage, right? And it's governed by rules we don't even feel. Well, today we're going to pull back that curtain and take a look at the stage itself, the very fabric of reality, space-time. So let's just start by questioning, well, everything. Think about it. Is it possible that time is ticking by differently for me than it is for you, right this second? And could the empty space between us, could it actually bend? The answers to these questions they're not just weird. They're going to completely change how you see the universe. Okay, so to really get how wild our modern view is, we first have to take a trip back in time, back to the world that Isaac Newton saw, a world that was perfect, orderly, and honestly, it just made sense. It was like a giant clockwork universe. So for Newton, space was basically the ultimate container. Just picture this giant, invisible box that holds everything, the entire cosmos. And this box is totally rigid. It doesn't bend, it doesn't stretch, it just is. It's the fixed stage for everything. And along with this absolute stage, you had absolute time. Imagine one single universal clock for the whole universe, just ticking away at the exact same pace for everybody, everywhere, no exceptions. A second for you was a second for me, was a second on Jupiter. Nice and simple, right? So the big idea in this classical picture is that perfect separation. You've got space, the stage, and you've got time, the clock. Two totally separate things. And this common sense view of the world seemed totally solid, unshakable. That is until a young patent clerk came along with an idea that just blew it all apart. And that revolution, it really kicked off in 1905. The man, of course, was Albert Einstein, and his big idea was the special theory of relativity. And it was all built on just two ideas. He called them postulates that seemed simple on the surface, but they would force us to rethink, well, everything. Now, the first idea wasn't too crazy. It's just that the laws of physics are the same for everyone who's moving at a constant speed. Makes sense. But the second one, oh man, the second one was a bombshell. It said that the speed of light in a vacuum is always the same for everybody. It doesn't matter if you're racing toward the light beam or running away from it, its speed never changes. And this just creates a massive problem for our intuition, right? Because if you're in a super fast spaceship chasing after a beam of light, you think the light should look slower to you. But Einstein says, nope, its speed is the same. So, if the speed of light is the one thing that can't change, then something else has to. And that something else? It turned out to be space and time. Our rulers and our clocks suddenly had to become flexible. One of the absolute wildest results of this is that the whole idea of now just falls apart. I mean, think about this. Imagine two lightning bolts hit the front and the back of a moving train at the same time. For someone standing on the ground, they'd say, yep, happened at the same time. But for someone on the train, they'd see one strike happen before the other. So who's right? They both are. It means there's no single universal now for the entire universe. And it was actually one of Einstein's old professors, a guy named Hermann Minkowski, who really grasped the huge implication here. He realized Einstein hadn't just discovered some weird quirks about moving fast. No, he'd stumbled upon a completely new geometry for reality itself. And this led Minkowski to make this incredible statement. What Minkowski showed was that space and time, they aren't two different things at all. They're actually woven together, inseparable, part of a single four-dimensional fabric that we now call space-time. So this is the new stage for all of physics. See, we don't really live in a three-dimensional world that just evolves through time. We actually exist in a four-dimensional block universe. Every single thing that happens, an event, has its own unique address. You've got 3 coordinates for where it is in space and 1 for when it is in time. Yeah, think about your own life. Your birth, that's one specific point in space-time. You, listening to this right now, that's another point. Your entire life, from beginning to end, can be mapped out as a continuous line. Physicists call it your world line that winds its way through this 4D landscape. And this gives us a new kind of absolute truth, something everyone can agree on. So while you and a friend whizzing by in a spaceship might disagree about, say, the distance between 2 events or how much time passed, you would both calculate the exact same number for what's called the space-time interval. That is the new true measure of separation. It replaces Newton's old separate ideas of absolute space and absolute time.
But wait, Einstein wasn't done, not by a long shot. About 10 years later, he came out with his general theory of relativity, which took this whole idea and turned it up to 11. He revealed that this space-time fabric, it wasn't just a passive backdrop. Oh no, it was an active player in the cosmic game. And this might be his most brilliant insight of all. He completely rewrote our understanding of gravity. See, gravity isn't some invisible force pulling things together. No, gravity is the shape of space-time. Mass and energy literally tell space-time how to curve. The go-to analogy, and it's a great one, is to imagine a stretched-out rubber sheet. If you put a heavy bowling ball in the middle, it creates a big dip, right? It warps the sheet. Now, if you roll a little marble nearby, it's not being pulled by the bowling ball. It's just following the curve in the rubber sheet that the bowling ball made. That's gravity. And this all leads to this really beautiful summary from the physicist John Wheeler. He put it like this: matter tells space-time how to curve. Curved space-time tells matter how to move. It's this amazing cosmic dance, a constant feedback loop between the stuff in the universe and the actual shape of the universe. So, get this. When we see the Earth orbiting the Sun, it's not being pulled by some long-range force. What's actually happening is that the Earth is moving in the straightest possible line it can through space-time that's been curved by the Sun's massive presence. An orbit is just what a straight line looks like in curved space-time. Okay, so this all sounds pretty mind-bending, I know. But it's not just a bunch of fancy math on a blackboard. The consequences of this warped, dynamic space-time are totally real. We see them all the time. I mean, we've seen starlight bend as it passes by massive objects. We know black holes exist, places where space-time is curved so much that nothing escapes. We've even detected gravitational waves, which are literally ripples in the fabric of space-time itself. Every single one of these things screams that Einstein's picture of reality is the right one. And remember, it's not just space that gets warped. It's space-time. Time itself gets stretched and squashed by gravity. This is called gravitational time dilation, and it means that the stronger the gravity, the slower time ticks. So a clock on the beach will actually run a tiny, tiny bit slower than a clock on a mountaintop. It's a minuscule difference, but it's real, and we can measure it. And this minuscule difference has a massive real-world impact. Think about GPS. The satellites orbiting Earth are in weaker gravity, and they're also moving really fast. Both of those things make their clocks tick faster than ours down here. Engineers have to constantly correct those clocks by about 38,000 nanoseconds every single day. If they ignored relativity, your phone's GPS would be off by miles within a day. So what's the big takeaway from all this? It's that the universe isn't a bunch of stuff happening in space and time. Space and time aren't the stage. They are a physical, dynamic thing that bends and stretches and ripples and evolves right along with everything else. Space-time isn't just the backdrop for the cosmic show. It's one of the main characters.